Welcome students to class today. So I will need you all to turn on your Zoom cameras because we will be discussing a few things today in class. And before we dive into the lesson, I'll give a brief explanation on each of the topics we'll be discussing. So we'll be starting with the null and alternative hypotheses. And the null hypothesis is an estimated statement that is commonly agreed upon, and the alternative hypothesis is always trying to reject the null hypothesis. And the alternative hypothesis can either prove or disprove the null hypothesis, and we can find out if the null can be rejected or not if we use a one-tailed or two-tailed test. And so imagine a hill, and the two bottom slope corners of the hill, those are our rejection regions. And the middle tall part of the hill is considered our acceptance region. And the boundaries that separate these two regions, they are called the critical values. And we'll get back to that. But how do we know when to use a one-tailed or two-tailed test? So we know when to use one or the other. If the alternative hypothesis suggests that the data will be less than or greater than the null hypothesis, and that will give us a chance to use the one-tailed test. Otherwise, we would use the two-tails test in any other situation. So a null hypothesis can sometimes be rejected even if it is true, and this is called a type 1 error. And it's not often that this happens, and the probability that it will happen is represented as alpha, and alpha is usually a fairly small number, but the probability that the null hypothesis can be rejected is shown as a p-value. And the bigger gap between the null hypothesis and the alternative hypothesis, that will give us a smaller p-value. And the p-value does this by considering the chance of the test statistic. And going back to critical values, the critical values that separate the acceptance region and the rejection regions, we use these critical values in forming our conclusion. And critical values can be represented such as Z, and we will use Z scores and a Z table in that instance, but we will know if our hypothesis was accepted or rejected by one of two things. So if our resulting data lies outside of the critical values, and that would be in the rejection region, then we know that the hypothesis was rejected. And if the data lies inside the acceptance region, inside the critical values, then we know that our data was accepted. So that will give us our result. So with all that said, turn to page 97 and we will jump into this lesson.